All right, guys, kind of got cut off on that last question. All right, the last question says, if Martin has a board that is 4 3/4 feet long, if he's cutting pieces that are 2/8 of a foot, how many pieces can he cut? So I started off by drawing a picture, trying to make sense out of the problem. I started off with my board that is 4 3/4 feet long. So 1, 2, 3, 4 holes, and 1, 2, 3/4 of another board. I have my last piece X'd out because it's not there. The question says that he's cutting pieces that are 2/8 of a foot long. So when I cut up my boards, I'm going to make them 2/8 of a foot. So I'm cutting my boards into eighths. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8 makes one hole. I'm going to continue to cut my boards into eighths and keep right on going, cutting them into eighths, cutting them into eighths. And my last 3 pieces right here, I can just chop right across the middle, and now they're not fourths anymore, they are eighths. And my pieces are 2/8, so for every 2/8, that's 1 piece of wood that I can cut. So there's 1 piece, because that's 2/8. 2 pieces, 3 pieces, 4 pieces, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 pieces of wood. And as I was doing that, it dawned on me that this is just like our burger problem, because I looked at my model and it looks exactly like our burger problem, except now we're talking about cutting pieces of wood instead of making hamburgers. But this is very similar to our burger problem when we made burgers that were 2/8 of a pound. So altogether, we could make 19 pieces of wood if we started off with 4 3/4 of a foot. In doing this problem, I can see that it's a division problem. I took a bigger amount and I chopped it up into smaller equal-sized pieces. So I'm going to do the division algorithm and just double check my work to make sure that it's the same. So I'm going to start with my 4 3/4 piece of wood that I'm going to divide into 2/8 size pieces and see how many pieces I can get. So if I use my algorithm, I'm going to do keep, change, flip. I'm going to change divide to multiply and make it 8/2. If I set up my box, I'm multiplying a mixed number by a fraction, so I'm putting my mixed number on top and my fraction on the side. And now that I'm looking at it, this is just really 4 wholes, so it's a lot easier to multiply by 4 than it is to multiply by 8/2. So I'm just going to swap that out for a whole number and then go through and multiply. I know 4 times 4 is 16. And 4 groups of 3/4 is 12/4. So that's a whole number as well. That's also 3. And 16 plus 3 equals 19. So it matches. Whether I drew the model or went through the algorithm, it's the same either way. The important part to remember is if it's a division problem, you have to make sure you're dividing. If it's a multiplying problem, you have to make sure you're multiplying. If the operation you choose does not match the situation or doesn't match the problem, you're going to come up with an answer that does not make sense. So let's check again if our answer makes sense. If we have something that's 4 3/4 feet long and we cut it into teeny pieces that are 2/8 of a foot, I'm pretty confident by looking at my model that 19 is a correct answer. We're going to get a lot of pieces out of that. I can get 1, 2, 3, 4 pieces out of each board, out of each whole board, and then I can get 3 pieces out of my small or short board, that piece right there. I can get 3 extra cuts out of my 3/4 board. So hopefully by looking at the model and thinking about the algorithm, we can come up with a solution for each one of these problems that makes sense. Hopefully this helped. All right, this is our last one. Looking at the problem number 6 on the back, it says Martin has a board that is 3 3/4 feet long. If he's cutting it into pieces that are 2/8 of a foot, how many pieces can he cut? I'm going to do the model and the division problem side by side just to show you that we get the same answer no matter what. If I draw this out, he has 4 3/4 feet of board. So I'm going to draw 4 holes and 3/4 of another to represent the wood that we started out with. So 1 hole, 2 holes, 3 holes, 4 holes, and 3/4 of another. And when I cut this wood up, I'm going to cut it into pieces that are 2/8 of a foot. So when I break my model into eighths, I'm going to make sure I cut all my pieces into eighths, and then I'm going to gather up all the 2/8 that I can find, because those 2/8 are going to represent the pieces of wood that I cut. So each one of my holes is broken down into 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8 in one hole. I'm going to take those 2/8 size pieces and count them up and see how many pieces of wood I can come up with. So this is 1/8, 2/8, but that's one piece of wood. I can do another piece, and another piece. So out of my first piece of wood, I can get 1, 2, 3, 4 smaller pieces. This is starting to look like our burger problem. There's another 2/8, and another 2/8, and another 2/8, and another 2/8. And I can keep going and circling up all my 2/8. I can get 2/8 and 2/8 and another 2/8 out of my bottom 3, remembering that that last piece is not there because my last piece, I didn't have 5 whole pieces of wood. I had 4 3/4. So let me count up all my cuts all together. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So I've got 19 pieces of wood. I'm pretty sure about that from my model. I started out with 4 3/4, and when I cut up my pieces, I made sure they were 2/8 each. Pretty sure this is a division problem, so I'm going to do it with the division algorithm and see if it also gets me the number 19. So I took my 4 3/4, and I'd be dividing it by 2/8 to see how many pieces or how many times 2/8 can go into 3/4. If I do my keep, change, flip algorithm, I'm doing 4 3/4 times, change divide to times, and flip to 8/2. Multiplying a fraction times a mixed number. I'm going to use my box model to do that. I'm going to decompose 4 holes and 3/4, and I'm going to multiply that by 8/2, which is the same thing as 4, I just noticed. It's a lot easier to multiply by 4 than it is to multiply by 8/2. So I can do 4 times 4 and get 16. And 4 groups of 3/4 is 12/4, which is also 3 holes, and 16 plus 3 gives me 19 holes. So either way, with the algorithm or the model, we both come up with 19 holes. Remember that when you're taking your quiz, you need to determine whether or not it's a multiplying problem or a dividing problem. Drawing a model can help you understand what is happening in your situation so that you choose the correct operation. Even if you don't choose the correct operation, you always want to go back and see if your answer makes sense. So if I have 4 3/4 of a feet of wood, my model really helps me see that if my pieces are 2/8, that I can cut 19 pieces out of it. So more than anything, I think my model helped me to see that 19 does make sense as an answer. Even though I did it, improved it with the algorithm, my picture really helps me see why it works. Hopefully this helps.